In this experiment we're going to use a demountable transformer to show how the potential difference at the primary and secondary coils of the transformer are related to the number of turns. Here you can see the core, which is made of soft iron with the laminated sheets to reduce eddy currents, coils of 600 and 300 turns that when you mount them on the core will allow you to change the ratios of the number of turns on the primary and secondary. The two voltmeters are measuring AC volts, and the power supply will use the yellow AC connectors because the transformer requires alternating current to work. I'm now going to set up the transformer as a step-down transformer by putting 600 turns onto the primary and 300 turns onto the secondary. I connect from the power supply to the primary coil, making sure I use the AC terminals, then connect the voltmeter in parallel across the primary coil. I do similar with the secondary coil, connecting the voltmeter in parallel to the secondary coil. This will allow us to measure the primary voltage and the secondary voltage. When I switch on the power supply, I can increase the primary voltage to 2 volts and see that the secondary is just under 1 volt. Increasing to 4 volts, the secondary is nearly 2. As I increase to 6 volts on the primary coil, the secondary is nearly 3. And at 8 volts on the primary coil, I get nearly 4 volts, seeing the ratio matching the 600 to 300. The ratio of the potential difference at the primary and secondary doesn't exactly match the ratio of the number of coils due to energy losses in the core. Now I swap to the other way around, and I've now got a step-up transformer, and when I switch on to 1 volt on the primary, the secondary is nearly 2. 2 volts at the primary, the secondary is nearly 4. At 3 volts it's nearly 6, and at 4 volts nearly 8, showing that the voltages are again in the ratio of the turns.